Should put all like all the examples be all homework questions.
No.
That sounds like a great idea.
Okay, so I have the quantity 2a cubed over b to the negative fourth, all raised to the negative 2 power.
I want to try this. I'm not.
I'm pretty sure we did not do this one yesterday.
No,
So
I
do
don't
we-
have that one on my page.
This is,
I think it's happening.
Hold on 1 second. We're thinking about it.
Hang on, I need to. My brain is quite dead. Wait, how do we do that?
So I know what to do if I have a negative on an individual term, but what happens if I'm taking the entire function to a negative power?
That we do it anyway.
To make it positive, we flip the entire function over. So everything in our denominator moves to our numerator. Everything from our numerator moves to our denominator. So this becomes b negative 4 over 2a cubed, all now to the positive 2 power.
Only because.
All because that was a negative.
what do you do?
We'll distribute the 2 in a second.
On the negative?
We'll get there. We'll get there.
Oh,
One thing at a time. One thing at a time. So because the entire thing was taken to a negative power, I had to flip the entire fraction over. When I did, my exponent changed from a negative to a positive. And now I can begin to simplify the individual numerator and denominator. So I'm going to go ahead and I'm going to take that 2 and put it on each term. So then this becomes, you can, but it's going to be easier this way. B to the negative 8, because negative 4 times 2 is negative 8, over 2 squared times a to the 3 times 2, which is 6. Right, we're okay with that?
I haven't processed this yet. Yeah. It's just kind of there.
I just put the 2 on each term, so I squared each term. Okay, where are we confused?
I've just been
You're okay.
process stuff one.
Yes.
Why did you do the negative 2 outside the parentheses and then the negative 4? Why did you do the 2 first?
Because if not, I would have had to distribute a negative 2 into everything, and I don't know what to do if I have 2 to the negative 2 power. So we don't want to distribute until it's a positive exponent. That's a really good question. Okay, so let's finish simplifying. The only thing I can continue to do is I can move this negative 8 down to the denominator, and I can square the 2. So then this becomes 1 over 2 squared is 4, a to the 6 stays, and b moves from the numerator to the denominator to become a positive 8. Because I moved the b negative 8 to the denominator, and I can't just leave it empty.
Okay.
So we have to put a 1 there.
That's
And then that is finished.
That's the answer?
That's the answer.
It doesn't look like that.
We're gonna do more.
Never say
I
that.
didn't say that, and I looked at the homework, and I couldn't figure it out.
That's okay.
Yes, you did teach us how to finish.
It is fun. Say that.
I
This
did like
is so
5
much
questions and
I'm
then
just
another 5
fine.
I was like,
That's
yeah.
what I don't know how to do it. I do it.
No, that's not how you do things.
That's how you do it.
You don't know how to do it, we figure it out.
That's how we do it.
Okay, has everyone written this? Yes. You wanna do another one?
Yeah.
I don't.
We're gonna ask them
anyway.
I think you can do
I can wait till you guys are ready, that's fine. Majority of questions arise because people are not paying attention. Okay, let's get through the lesson, then you can socialize while you do your homework. Sound good?
Yes.
Another example.
Oh, this is one of the one.
You have an exponent of 0?
We can.
Yeah, it just doesn't want I'm not.
It will become 1, but this is how it's initially presented to me. So we will simplify that in a second. So I have x5, y2, z7 over the quantity x cubed, y negative 4, z0, all taken to the third power. Everyone have it written.
Yeah.
What is the first thing we don't like?
The zero.
The 0. Okay, z0 is what, Wackle? 1. So this is the same as having x5, y2, z7 over x cubed, y negative 4, all cubed. It just goes away.
We just lose it,
We just lose it because 1 times anything is just that thing.
even if it's.
From here, my entire function is not being taken to an exponent, so I don't have to worry about that, which means I'm going to simplify in my numerator and my denominator individually. There's nothing I can put together in that numerator, so I'm going to focus on the denominator. What can I do here? Distribute that cube. So I'm going to cube every single one of those terms in my denominator. When I cube an exponent or when I take an exponent to an exponent, what do I do with them? We multiply. So this becomes x5, y2, z7. That was the numerator. Over x to the 3 cubed would be x to the 9th because 3 times 3 is 9. And negative 4 times 3 is negative 12. We're going to move in a second. Hold on. Just make sure everybody can get to this point. What am I logically going to do next?
Flip the y.
Why are we flipping the y? What do you mean by flipping it? Okay, so it has a negative exponent. I can't do anything with it until I make it a positive exponent. So we're going to move it up to the numerator. So I get a y positive 12 in my numerator.
Can you just add it with y?
Yes, and then we can add the y2 and the y12 together to get a y14. So I now have x5, y14, z7 over x9.
There's still more.
Yeah. How do we know that we're not finished?
Because we have to make x smaller, right?
I have an x in both the numerator and the denominator, which means my base is repeating. That can't happen.
Like what do you do?
I have an x here and an x here. I'm not done. I can only have one x in the whole problem.
Does it matter if it was just a y then, or a z? The bottom, or
If I had 2 y's, I wouldn't be done. If I had 2 z's, I wouldn't be done. I don't understand what you're asking. I think.
like instead of the x down below?
If that was a y,
Yeah.
I still wouldn't be done because I'd have a y and a y.
Okay.
As long as there's any repetition, you're not done. How do I simplify an x5 over an x9?
Well, the
You
bottom
go to the top x5 and subtract it by the bottom.
Okay, we identify which exponent is bigger and we subtract the other one from it. Clearly the 9 is bigger than the 5. So when I move that across, it becomes subtraction and I get x to the 9 minus 5. So simplified, answer is y15 z7 over x4. That's it. How are we feeling about this?
On our homework, if it's numbered, we have to put the ones that are numbered.
No, you have to put them, like, if I had 3 cubed, I would have to cube it.
Okay.
Yeah.
For the y, yeah, so like the y14 and put 2 there.
I'd have to take 2 to the 14th power.
Okay, and then you get 5.
If I have numbers I can simplify, I will. Yeah. I have a question for you. If I had a number, okay, so let's say theoretically I adjusted this. I made this a negative 14 and I put a 3 in front of it. When I moved that y to the denominator, would the 3 go with it?
No.
No. Please remember they are separate terms. Just because they're connected by multiplication does not mean they travel together. And that's a huge mistake and it will throw off your entire problem. Okay? I think we're pretty decent on those, so we're going to move into degrees of polynomials and then simplifying them. Okay, so when I'm talking about the degree of a polynomial, I'm talking about the term with the highest exponent value. Okay, so if I have something like x to the 7th minus 10x to the 5th plus 11 x squared minus, I don't know, x to the 20th, what's the highest exponent present in this problem?
20.
So this would be a degree 20 polynomial. Or you could say 20th degree, it's the same thing. It doesn't matter the order or the number in front of it. We go simply off of the highest exponent term. That would be it. If I asked you to identify the degree, it is simply the highest exponent present. Okay, so what if I gave you another one? Let's say, I don't know. Five, highest exponent there, correct? Is anybody confused by how to identify the degree of a polynomial like this? No, we're pretty good, right?
Absolutely.
So what if I didn't just have one variable present in my polynomial? What if, for instance, I had something like, oh, I don't know, 3x squared y cubed minus 4y to the 5th plus 7x cubed y cubed minus x. It's actually not. So when we have variables connected by multiplication, I'm no longer looking at a single exponent. I'm looking at the sum of the exponents for each term.
Also, if you take like 2 times 3.
So on this term, 2 and 3 add together to get 5.
Oh.
On this term, I just have one variable, so that's going to be a degree 5 term. What about this term? That's a 6. 3 and 3 is 6. And then this one is a 1. So what is the highest degree term combination I have? 6. So this would be a 6th degree polynomial.
I thought you meant the times the whole.
Nope. Each term individually. We just check it out and find which one is the largest.
You just degree 5 or
6th degree. 6th. Degree 6, 6th degree, same thing. Does that kind of make sense?
yes.
So if we have more than one variable connected by multiplication, we have to add their exponents together. So then what if I gave you, let's say I gave you negative 21 x, y, z 5, a 3, b 1. Oh, I don't want 1, I want 4. I just want to know the degree of that term. It does look stupid, but that's okay.
What's the point of this?
You just add them all together.
You'll see what the point is. We just add them all together, right?
14.
I have 4 and I have 3, which is 7, plus 5 is 12. My x and my y don't have an exponent, so I don't have to add those, right?
No, that's not
Yeah,
so.
1.
No, but there are 1. Just because it's not there doesn't mean it doesn't exist. So it is, in fact, a degree 14 monomial or polynomial right here. Any questions on that?
You're just counting
The exponents.
and then adding them all. I did that, but I don't know why you would do that any different than the first one. I don't understand.
I'm showing you that if, okay, so the first one being this one, right? On each of these, I only had an x. So it was really easy to just figure out which one had the highest exponent. On these, I have to add them up because even though this one has a 5, which looks to be the highest exponent, the sum of 3 plus 3 was greater. So this was actually degree 6 because the sum of my exponents was the largest on this term. Okay, that is not on your homework this time. You only have single variable polynomials on your homework.
Oh, is that the first two?
Yes.
Okay, I didn't.
Yes.
Like 7 is separate, 5 is separate, but over here 2 and 3 is not separate. They're not related.
That's good, both. Yeah. If it's connected by it, or if it is separated by addition or subtraction, they're considered different terms. Okay. So that's fairly easy for the most part, right? Very straightforward. I know it gets a little complicated when we have more than one variable, but the more we do it, the easier it will get. So the last thing I really want to cover with you is combining terms in a polynomial, because I know some of you kind of struggled with this yesterday when you looked at the homework. So let's say that I am given this product problem.
I think my head hurts from looking up and down so much.
It probably does, I'm sorry. We only have like 2 examples left, so it's not that bad. Okay, let's say I have x minus 5 times x squared minus 2x plus 3. In order to simplify this, I first have to expand it through multiplication. How would I do that here? FOIL, distribution, whatever you want to call it. So I'm going to take this x and I'm going to multiply it into each of the 3 terms in my second polynomial. So I have x times x squared for my first one, minus x times 2x, or I guess I could say 2x times x. Then x times 3, and then I move on to the negative 5. I'm going to multiply negative 5 then into all 3 of these terms, which leaves me with negative 5 times x squared plus 5 and 2x, because a double negative becomes positive, and then minus 5 times 3. I simplify it out by actually doing the multiplication. X and x squared becomes x cubed. 2x and x becomes 2x squared. 3x stays the same. Negative 5 and x squared becomes negative 5x squared. 5 and 2x becomes 10x. And negative 5 and 3 becomes negative 15. I'm going to pause here. I just multiplied each term out. So what do you think each time? Are you thinking what to do next? Okay. So my goal here is clearly going to be condense this by putting like terms together. But how do I identify my like terms?
By what?
Nope, not by what the x has in front of it. I actually have to look at the base and the exponent to make sure they are identical. So my first term here is an x cubed. Do I have any other term that has an x with a 3 exponent on it?
No.
No. So this cannot be simplified with anything. So it must remain in my final answer. Then I look at my next term. I like to move left to right. It's a really good system. I have a negative 2x squared. I now need to look for another term that has an x squared on it. Negative 5x squared. I can then combine them by addition. So negative 2 and negative 5 becomes a negative 7. And then their variable and exponent remain the same. So negative 7x squared. My next term then is 3x. What can I combine that with? The 10x. 3 and 10 become 13, and my variable stays the same. What do I have left? I can't combine that with anything because there's no other constant term with no variable. So I just have the minus 15 at the end.
Would that be the final answer?
That's your final answer. No. How do we feel about that?
Just
now.
Just long. I do get that. Kind of like it? Okay, I'm going to give you one to do on your own. And then we will be done with today's notes. Sound good? Okay.
Then we watch a movie.
That's next.
Yeah.
What?
I read the book. I know
Okay, there you go. On your own, please solve this problem. And by solve, I mean expand it through multiplication and then simplify by combining like terms.
Is there like another way?
This is the easiest way. How many feet does that chair have? Let's keep them all on the floor, please.
Wait, can you?
But
Can you walk it right to left?
It does not matter the direction, so yes, absolutely. What's your question?
there was one way that it was like so much more difficult. I watched it on YouTube. Awful.
Awful.
It was like I was just like, okay.
It could have been like binomial form, but it's like expansion, expansion.
Yeah, it was just awful. I still did it though. So.
True.
Yeah, because I only care about
Yeah. That's
Oh my God.
So could I just take the extra -1? 0 times 5 is 0. And also, why didn't you write down your? Oh, never mind. No, that's a whole. Why didn't you write it down? Oh, but you didn't write down what I wanted. We always do so you take your factor.
Do you add the exponents together?
No, exponents say, well, when you're multiplying, yes, sorry. When you're multiplying, yes.
I mean, down. I just
What? Did you ask me?
I was trying.
To a speech, she said, I'm not ready to speak.
Okay, are we ready?
I'm not even done.
No.
Yeah, it was 1 second.
Okay, I'm going to slowly start doing the multiplication so that if you are finished or if you get finished, you can check your work with mine. And then we'll do the combining together.
Just like 6 executing? Oh, no. Oh. What?
I really like cheese. I didn't think I would.
Because I understood this.
I just always forget the rules for like.
That's what I could.
You also could have done from the binomial to the four-term polynomial. It would have worked the same way. Left to right or right to left does not matter.
I think that was with. You're talking about matrix.
I'm running like 2 miles.
Are we all ready to start combining like terms?
Yes.
Yes.
Yes. Where? Here? 2 times 3 is 6.
I feel like
I don't know. It might have added. It happens.
Added.
The more you do it, like the more like your brain just messes it up. It's fine.
Mr. And I feel like this one's a lot like easier than the homework because the homework is all unorganized and you have to like.
You have to organize it
Yeah.
yourself. Yep. I love those.
This one's like.
Kendra, is there anything I can put together with the 6x24?
No.
No, it stays exactly how it is. I also like to cross it out when I'm done with it to make sure I hit every term. I don't know if you guys like to do that, but that's what I like to do. Moving left to right. Is there anything I can combine with the negative 4x cubed?
15 minutes. I did it. Yeah.
The 15x cubed, what's negative 4 plus 15?
I use 11.
11.
I use 5.
And then the x cubed stays the same.
Okay, why? I put negative.
Christina, is there anything I can put together with the negative 10x squared? And what do I get when I put those together? Negative 28x squared. Miranda, is there anything I can combine with the 12x?
No.
There's nothing else that has an x in it.
Oh, I didn't have that, because I got it wrong.
Okay,
So yeah.
Is-
There's a 12x.
so I can put those together.
I just figured out that I did it wrong, so we just had it. Then you called them.
I'm sorry. So I have a 12x and a 3x that I put together. And then I have the minus 2 constant on the end. So then this is my polynomial answer.
I forgot to mark some as square and some as sharp.
It happens all the time. All the time.
Oh, what the heck?
Any major questions, concerns, or issues with this?
I figured out what I did wrong.
Because I tried to do it.
Okay. Homework is on Canvas, the same one you worked on yesterday. Please feel free to work with your peers. Please. You guys learn better when you bounce ideas off each other.
No, it was just like.
Pass me this.
It's interesting and it's depressing.
So.